Welcome. In this video we're going to look at the SNS to SQS Fanout architecture. This is quite commonly used. It's a common question in exams as well. Essentially we have an SNS topic which then feeds into a couple of SQS queues. It can be more obviously, and those SQS queues are then processed by perhaps an EC2 instance. When we set this up, we're not going to create the EC2 instances, but we will do the SNS topic and two SQS queues. Now, you might ask, why would we do this? Why, for example, if we wanted to send a message, couldn't we just have the SNS topic feed directly to the EC2 instances? Why do we need the SQS queue? Or, why wouldn't we just use SQS and feed that into the EC2 instances and not have an SNS topic at all? So you've got to understand that SNS is a publisher-subscriber system. So this means that when it receives a message, it forwards it on to the subscribers. It doesn't queue up the messages. So if your application is processing images and that takes some time, you may not be ready to receive the next message when it comes in. Similarly, there is an issue with SQS in that that does queue things up, but it's not designed to send messages or for multiple receivers to actually process the messages. So with SQS, when someone grabs a message or one component grabs a message, it won't be there for the next component. Typically the idea with SQS is you grab the message, you process it, and then you delete it. And that means that the other components don't grab the same message, so you don't double up on the processing. So essentially, to achieve an architecture where you have a message coming in and it's queued up for multiple components to process, you need to pair SNS with SQS. So what we'll do first is we'll create the SQS queue, and we can do this in AWS Console just by searching for SQS. I've got it here already. If you haven't created an SQS queue previously, then you'll arrive on this landing page, and you can just click Create Queue, and that basically creates a queue for you. Now, when you do this, it gives you a few options. First of all, you have the option of either having a standard or a FIFO queue. So with a standard queue, it's a best effort ordering of messages, whereas with a FIFO queue, the ordering ensures first in, first out delivery. Now, depending on your application or use case, you may or may not need the messages to be received in order. It may not be relevant for other applications. For example, maybe processing images. It doesn't matter if they're out of order. For some kind of order processing or accounting setup, perhaps you need those messages to arrive exactly in the correct order. So what we'll do is we'll create a queue. This one we'll call this for example, billing queue. Right, and then we have a few configuration options. So there's a visibility timeout. This visibility timeout is basically the time after a message is received by a component that it would actually reappear for it to be a different receiver to receive that message. Now, you might ask why you do that. The common scenario might be, for example, you're processing an image and that it fails for some reason. So you want to be able to ensure that that message does get processed ultimately. So because the processing crashed after a timeout period, it'll automatically become visible again for a different receiver to process it. Then you have a message retention period. The message retention period is just basically how long that the message will still remain in the queue. Yeah, that can be quite a length of time if you want it to be there for days. It really depends on the use case. Obviously, you might want to set that to be shorter if messages become stale and don't need to be processed, if they're time sensitive. Delivery delay. This allows you to set a delay after the messages are received before they become visible. And then there's a message size. It's not intended that SQS messages are huge. You could also always use things like S3 to actually store large chunks of data and just provide the URL for that in the message itself. But otherwise, you can just put the data directly in the message, which would more likely be the case if you were processing doing an ordering system or similar. And then that's basically, then the last one is the message wait time, and this is used for polling. The idea is that, if you poll and there's no messages, you have to keep on polling again and again. So if you don't want to keep polling like that, you can set it up to a 20-second wait time where you poll, and essentially, you wait up to 20 seconds, and in that time, perhaps another message could come in, and you can return that message once it does come in. It's more efficient way to poll effectively. Your other options, we'll leave those at the defaults. Moving down, you can define an access policy. Now, we're going to go with basic here. You do have the option to do an advanced access policy. But if you select basic, then we basically only allow the queue owner to send messages and to receive messages. And you can see that here on the right-hand side. Essentially, we're allowing it's defining the principal, the action, which is basically anything on SQS, and then the resource, is the billing queue. So, if we keep going down, there are options for encryption, dead letter queue, and also tags we can set. But we'll leave those as they are at the defaults, and we'll just click create queue. Right, so now the queue's been created. It's called billing queue. If you want to see it in action, you can click send and receive messages, and you can write bill number 1 as the message, and just click send, and the message has been ready to be received. It's in the queue. So you can see it if you scroll down by just clicking poll for messages, and there it is there. It's got an ID, and the body of the message is there. It gives you details about size, ID, MD5, and so forth. But billing number 1, and the idea is, of course, that would be ultimately processed. So perhaps by EC2 or some kind of Lambda function might grab that and do processing. What we'll do next is now we've created the SQS queue. We're going to create SNS as well, a topic, an SNS topic. So we'll do here SNS topic. Okay, wait for that there to load. Right. So when you go to SNS, if you haven't created topics before, you'll arrive on this landing page, and then you need to create a new topic. And we're going to call this order topic, and click next step. So again, you have the option of FIFO or standard. Again, the same kind of thing as SQS, where you have a best effort, and at least once delivery. So if you chose FIFO, typically that's slightly more expensive, but basically it'll ensure the order and exactly receive messages only once. So again, depending on your application, it may or may not be important for messages to arrive in order, and it may or may not be important for messages to be received only once. I mean, obviously you wouldn't want to double bill someone, for example. Right, so we've got here order topic is the name of our SNS queue. So what we'll do next is we have some other options: encryption, access policy, retry policy, delivery status logging. Now we are going to click on delivery status logging. What we want to do is we want to log the status. Which protocols do we want to log it for? We want to log it for SQS. And what percentage do we want to log? Now, obviously, if you're receiving millions of messages, you don't want to log them all. You may just want a proportion of them. You know, maybe 1% of them, for example. But in our case, we're going to log them all to CloudWatch, and then use an existing role or create a new service role for this. This is so that it has permissions to write to CloudWatch logs. We'll create a new service role, and just click on that and create new roles. Opens a new tab, and essentially it's pretty straightforward. Here you go, IAM role, and essentially we give you the details here. So success feedback, failure feedback, create a new role policy. So yep, we'll just click on allow, and this will give SNS write access to the CloudWatch logs. And we do want to be able to write failures and successes, I should say, to CloudWatch. If there is a failure, then yeah, it's certainly a case where you would want to be able to have that in CloudWatch so you can diagnose what's going wrong. Just click allow, and that'll bring you back to SNS. Yep, and there you go. The roles are there. Are now populated, and that means that we will have permission to write to CloudWatch. So click create topic. Okay, now I've got no subscribers. You can publish a message, and you know, you can test message. Test message, and you can do time to live, and you can do message body, and you click publish message. Now, at the moment, we haven't got any subscribers, so that's not going to do very much. So we really need to be able to add subscribers to this. Now, you can create subscriptions here from within SNS, or you can do it from SQS itself. In SQS, you can go to our billing queue, for example, and then we can look for SNS subscriptions. We can subscribe to an Amazon SNS topic in here, and then we'll say our order topic comes up, it's populated. So you click on that, and you click save. Now, that's created the order topic as a subscription. So now what we want to do is we're going to try and send another message and just see if it comes through. So we'll publish a new SNS message. We'll call that order number 100 as a subject, and we'll give it a body, 12 eggs. And publish message. Right, now we want to know if that got through. So let's jump over to SQS now. That because SQS is a subscriber to the to SNS topic, what that means is it should arrive in the SQS queue and send and receive messages in our queue, and we do another poll. I've got two messages here. Now don't forget we sent one earlier. So the first one here, if you want to look at that in terms of this one was bill number 1, and then this one here is number 2, and if basically this gives you the SNS topic details. So remember we had a message with the subject of order number 100, and it was 12 eggs. So that is working, as you can see, but it's not really a fan out yet because we're only receiving to one SQS queue. So we're going to go back to our SNS topic. Sorry, we'll do it from SQS, and we'll add more. We'll add more subscriptions on here. So sorry. refresh that. So we go to what we'll do is we'll create a new queue. The previous one is called billing queue. This one we're going to call it dispatch queue. Now again, the idea here is that in a serverless architecture that where the different components are completely detached from each other. So you don't have for example, the billing queue calling the dispatch queue. The idea is that they all receive the message from SNS and they do the relevant processing, which keeps the complexity, I guess, concentrated within the individual piece of processing. So you don't have to have billing doesn't need to know about dispatch. Dispatch doesn't need to know about billing. The complexity essentially lives in the architecture that sends the messages between the different components. So we'll continue with this. Again, this is going to be a standard queue. We'll do so we're calling it dispatch queue. And again, basic access policy on this one. We won't modify any of that. We don't have dead letter queue, encryption, or tags, so we just click create queue. And then here's our queue here. It's been created. So we have dispatch queue. So what we want to do is we want to have SNS subscriptions. So we can click on the topic, and we'll go to order topic again. So this is a previous one up here. This is our order topic here. You can see 1136 order topic, and that's the one which I've selected here. Click save, and this is the dispatch queue. So what you might want to do is go back to queues, and so now we have both the billing queue and a dispatch queue, and when we send an SNS message, it should go to both queues. So we'll publish another message. I'm going to call this message 101, and then we're going to say one loaf of bread, and click on publish message. Now we get some feedback here. It's just published successfully. We'll close this. Actually, if we go to here, we see the subscriptions as well. So you can see both. You've got the dispatch queue and the billing queue. And if we go to these queues, so we'll open them in different tabs. We'll go to billing queue. Sorry, we've got billing queue and dispatch queue. So now our billing queue, we'll do we'll go to send and receive messages. And then what we'll do is we'll poll. And so we have a message here. So if we have a look at these, so look at the most recent of the messages. Click here, one loaf of bread, and there's a message 101. And then if we go to the dispatch queue, we also can send and receive messages. In the dispatch queue, we poll this one, and we just have one message in here. Again, the same thing, one loaf of bread, message 101. Now we still have the other messages in the original billing queue. That's just because these are the ones we sent originally. Our original there's bill number 1, which is the original test message we sent. There's the 12 eggs message. Sorry, I should highlight that. 12 message order number 100. And then there's the most recent one, which is message 101, one loaf of bread. So you can see that basically one SNS topic is delivering to two subscribers being two different SQS queues. The idea here, because we've got dispatch queue, billing queue, we could have other processing that goes on. We could have a queue for perhaps increasing the number of loyalty points as a result of a purchase as well. Again, removing that complexity and knowledge from the different components, and so they can be designed to just focus on their specific function, and with complexity removed. So typically you might have these queues be received by or processed by something like an EC2. If you're doing large image processing, then you'd fire up some EC2s. You'd some auto scaling perhaps, depending on the number of items in the queue. But we're not going to get into that here. It's just really to demonstrate basically the basic architecture. So I hope that's been helpful. Certainly give me a comments and your feedback. And yes, thank you very much.